everyone, this is Algebra 1, Topic 2, Linear Equations. The topic essential question is, why is it useful to have different forms of linear equations? And it already tells you that we're going to have different forms of linear equations. And you get a hint that it's going to be useful. Let's look at the lessons here. We have 4 lessons in this topic, and it includes slope-intercept form, point-slope form, standard form, and parallel and perpendicular lines. So the topic vocabulary would be parallel lines, perpendicular lines, point-slope form, reciprocal, slope-intercept form, standard form of a linear equation, and y-intercept. We will start with slope-intercept form in lesson 1. Okay, 2-1, slope-intercept form. In this lesson, we'll be able to write and graph linear equations using slope-intercept form. The lesson vocabulary would be slope-intercept form and y-intercept. Let's start with model and discuss. Alani wants to buy a $360 bicycle. She's considering 2 payment options. The image shows option A, which consists of making an initial down payment, then smaller equal-sized weekly payments. Do you know what a down payment is? So you need to pay the full price to buy a bike, right? It's a $360 bike, but down payment is what you can pay right now. So maybe you pay half, and then you pay the rest of it in a small increment over time. So you don't know how much down payment is and how much you're gonna pay for the weeks, but that's the idea, okay? Option A has an initial down payment. She's gonna pay a little bit and then pay the rest of it weekly. So eventually she'll pay the whole price, but she's gonna divide the payment so that it's less stressful for her to spend money. Option B consists of making 6 equal payments over 6 weeks. So down payment would be you usually pay a little or more. You usually pay a lot more or a little bit more than what you would pay every week. But option B doesn't have the down payment. She's just going to divide it in 6 equal parts and pay it every week. So think about those 2 options, and let's answer parts A and B. Part A. What factors should Alani take into consideration before deciding between option A and option B? So what factors is she comparing? What makes her choose option A? What makes her choose option B? What is better for her depends on what factors. She could think about how much money she has right now that she can use for a bike. She can think about how much she can pay and would be okay with it, right? So the factors that she need to consider would be her income and her expenses. If she know how much money she is going to use for other necessities and other things in her life, she can think about how much money she has left after she uses all that money, right? So thinking about income and her expenses would give her how much money she could make a down payment, or if she can't, she would have to divide that into 6 equal payments. So writing that down, we can say Alani should consider her regular income and expenses. Part B. Suppose Alani could modify option A and still pay off the bike in 5 weeks. Describe the relationship between the down payment and the weekly payments. What is the relationship between the down payment and the weekly payments? If down payment goes up, the more you pay down payment, what happens to your weekly payments? Do they go up together as well, or do they go down? Think about your full price. Your full price is already decided. It's determined, right? It's a $360. If she pays a down payment of $100, okay, this is just an if. If she makes the down payment of $100, you divide 160 into 5. And then you'll pay small increments on a weekly basis. So you have, if you pay $100, you have $260 left, and that means you're going to pay $52 every week. What happens if your down payment goes up? If she pays more money, if she pays $200, then she would need to pay $160 over the next 5 weeks, right? So if you divide 160 into 5, you get 32. So every week she's only going to pay $32 each. So what is the relationship between the down payment and the weekly payments? The more she pays for the down payment, the less she has to pay for the weekly payments, right? The less she pays for the down payment, she owes more money, so she's going to pay more for the weekly payments. So that's the relationship between them. Let's write that down. You can say if she makes a larger down payment, Elani will have smaller weekly payments. If she makes a smaller down payment, she will have larger weekly payments. Okay, so that is a good example to get started thinking about equations in slope-intercept form. So the essential question is, what information does the slope-intercept form of a linear equation reveal about a line? What kind of information does it reveal, and how is it useful is what we're going to look at. So for first example, graph a linear equation. What is the graph of y equals 4 over 5x plus 2? The equation is in a slope-intercept form. So if you are not familiar with a slope-intercept form, your slope-intercept form is y equals mx plus b, where m is slope and b is your y-intercept. Okay? Y-intercept means when your line intercepts your y-axis. So all the points here could be y-intercept, but only the intersection point between your y-axis and the line should be your y-intercept. And you always have an x value of 0. So 0, comma b is your point of your y-intercept. And that b goes into your b over here in the slope-intercept form. Okay? And x and y, they're just points on your line, right? They could be any point, x, comma, y. Okay, they could be any point on the line. It has to be the points on the line. There are infinitely many points on the line, but there are also other infinitely many points on the coordinate plane that's not on your line. So it has to be the pair that's exactly on your line. If x is 5, there's a specific number that y has to be on that line. 6 has to be your y value on this line. Okay? If x is 5 and it's other numbers like 4, 5 comma 4, 5 comma 8, the points are not on your line. So you need to have a pair, a specific pair of x and y values for your point on a line. Okay? So those y and x just represents any numbers, but they need to be specific to each point, to the other pair. Okay? So step 1, we're going to identify the y-intercept in the equation. So in order to graph this, you're going to identify the y-intercept in the equation. If you look at this form, it is in a slope-intercept form. You can see that 4 over 5 is your m, your slope, and 2 is your y-intercept, right? That means your slope, m is 4 over 5. What does your slope mean? What does it mean to have a slope? It means the direction the line is going, or the speed your line rises up will be determined by the slope. So that's going to be rise over run, which means you're going to count the number of change in y. How many blocks are we going up or down for y, right? How many blocks are we going left and right for x? And those are going to make a slope. So after you identify your slopes and y-intercept, what do? Well, if you have a slope-intercept form, it's really easy to graph if you start with the y-intercept. Your y-intercept tells you one point that is definitely going to be on your line. Your x is always going to be 0 for your y-intercept, but your y value is your y-intercept here. 0, 2 is the point that your line intersects on the y-axis. So 0, 2, right here. You're going to start there, okay? And then you're going to use the slope to plot a second point. From here, so disregard the line. You don't know where the line is. You're going to start with one point, the y-intercept. And then your slope will tell you the change of your points, right? So starting from this point, if you start with any other points on the line, you should be able to count the slope and get to another line, another point that's on the line. So it doesn't matter which point you start with, you just have an easy point already given to you by the equation, right? Y-intercept is 0, 2. So that's why you start with 0, 2. And you're going to count the slope. How much are we changing vertically is what the number is on top. So vertical change is 4. Vertical change is 4. It's a positive 4, so that means you're going to go up 4 times. 1, 2, 3, 4. Okay? And then horizontal change is left or right. Left is negative, right is positive. So that's negative, that's positive, that's positive, that's negative, right? So positive 5 means you're going right. 5. 1, 2, 3, 4, 5. And then together they make the next point. You can't just count one vertical change and then say, oh, that's our next point. No, you have to have both of them because your slope is 4 over 5. You need to count both of them at the same time. So from this point, you count the vertical change and you count the horizontal change, and that is your next point on the line. So 0, 2 and 5, 6 are 2 points, and you can draw a straight line that goes through the 2 points. If you want to check if your line is straight and is correct, you can pick another point here, or you can pick a random point on the line that looks, it's kind of hard to tell. So you can keep going with your next point, right? 1, 2, 3, 4, go up 4. 1, 2, 3, 4, 5. Go right 5, and that should be your next point, and your line looks straight. Okay? If you choose any other point on the line, it should be the same. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Okay? So if you choose any point on the line and you count the slope, you should have the next point on the line. Okay? So that's how you draw a linear equation using your slope-intercept form. So now it's your turn. Sketch the graph of y equals negative 3 over 4x minus 5. See if you can graph it by yourself. If you have a graphing paper, you can graph it on the graphing paper, that would be great. Okay, are you ready? Yeah, so I have a graph here. So if you have a graphing paper, that would be the best. But yeah, if you do have a graphing paper, you should draw the x-axis and the y-axis and label them. So the vertical one is the x-axis and the horizontal one is the y. The vertical one is the y-axis, horizontal is the x, as shown in my paper here. Okay, once you label that, you're gonna start with your y-intercept. So -5 looks like it's your y-intercept, right? And if it's subtracted, if your 5 is subtracted, your y-intercept is -5. So you have a 0, 5 for a y-intercept. And your slope is -3/4. What happens if you have a negative slope? That means you can either have -3, so you go down 3, and then you go right 4, +4, or if you do +3 and you go up 3, you have to go left 4, so -4. But the negative could be on either side of the fraction. And it should work if you're counting it correctly. It's just gonna go the same direction. So it's like you go up and right here, right? For example. But then that's the same as you go left and down. Because your positive slope is also -4 over -5 makes a +4 over 5 as well. So it could go the other way as well. -4, -5, -4, -5, -4. Or you go up 4, right 5, up 4, right 5. Does that make sense? For negative, you could go down 3, right 4, or you could go up 3, left 4. But they should be the same line. So on my piece of paper, I'm gonna start with 0, 5. Make sure you label your grids as well. 1, 2, 3, 4, 5, 0, 5. So that's my first point. You see that? That's my y-intercept. And then you're gonna count your slope. -1, 2, 3, and then you go right for 1, 2, 3, 4, and your next point is right here. Okay, go down 3, right 4. Or you can go up 3, 1, 2, 3, and then left 4, 1, 2, 3, 4. Okay, or you could go this way. But they should all make a straight line. So draw a straight line across all the points that you have counted. You should be able to make a straight line through the points. And this is the answer for number 1. Wait, I'm so sorry. Why did I write +5? Your y-intercept should be 0, -5. So you start with -5 actually. -1, 2, 3, 4, -5. And then you count it again. 1, 2, 3, 4. Wait, you go up 3, you go left 4. And then you make a straight line through that. Okay, I crossed that out. So that should be your real answer. Okay, it starts with your y-intercept, and then you need to count up 3, left 4. Or from here, you can also count down 3 and then right 4. So either way, it should work. Okay. Let's look at example 2. Write an equation from a graph. What is the equation of the line and slope-intercept form? Step 1. Find the slope between 2 points on the line. What if you have a graph and you want to write the equation in slope-intercept form? So we're going to go the other way. If we look at this graph here, you can point out some important points, right? You can find the slope between 2 points. So you need 2 points in order to find a slope so that you can count how many changes there are vertically and horizontally. So we have these 2 points pointed out from the graph, 0, 1 and 4, -2. So you can count from one point to another how many have you moved. So 0, 1, from here you go down 3 units and you go right 4 units. That means your slope is -3/4. Does that work the other way around? What if you start with this point? Yeah, that works. 1, 2, 3. You go up 3, so that's +3 on your numerator. And you go 1, 2, 3, 4, -4. So left 4, right? So you have 3/4 as well, which is all the same as -3/4. Okay, that's your slope. Find the y-intercept. Where does the graph intersect the y-axis? Right here, 0, 1. Because your point is 0, 1, your b is always going to be 0, b. So the y value of your point, y-intercept point. So your b is 1, y-intercept is 1. And then you're gonna use those information. As long as you have slope and the y-intercept, you can write the equation in the slope-intercept form. So fill them in, substitute their values in this y-intercept form. Y = mx plus b is a generic form. This is the y-intercept, no, this is the slope-intercept form. Okay? That's not your answer. That could be any equation. That doesn't tell you any specific line. You need to write numbers for your slope and your y-intercept. Otherwise, your line is not complete. The only variables you should see in the equation of the line should be x and y. M and b are not variables. They stand for a number. They should be a specific number in your equation. Okay? So the equation of the line and slope-intercept form for this graph is y = -3/4x plus 1. Okay, just plug in your slope and your y-intercept. Alright, now it's your turn. Try number 2. Write the equation of the line in slope-intercept form. Looking at this graph and pointing out the 2 points and labeling them, figure out the slope. And using the y-intercept, you can figure out the y-intercept and write the equation in slope-intercept form. Pause the video, see if you can do it by yourself. Come back when you're ready for answers. Okay, are you ready? So what are the important points here? You see these 2 points. How do you label them? You count them. So your point always has to be x, y. So count the x first, 1, 2, 3, and count the y, 0. So that's 3, 0. And what about this one? Your x is 0, your y is -1 and 2. And so your points are 0, 3, 0, and 0, -2. Which one is the y-intercept? This one is the x-intercept. And your y value is always 0 for your x-intercept. And it goes through the x-axis. So it's called the x-intercept. But Your y-intercept is this one. It goes through the y-axis, and your x is always 0. Okay? So your y-intercept will give you your y value -2. So b is -2. Let's count the slope. From here to here, let's go up 2 units, so +2 over 1, 2, 3. Right 3 units, so you're going +3. So 2 over 3 is your slope. That means your equation of the line in slope-intercept form should be y equals +2 over 3x minus 2. Okay, check your answer. See if you got it right. If you did, good job. Okay, let's look at example 3. Understand slope-intercept form. How can you find an equation of a line that passes through 2 points if neither of them is the y-intercept? Ooh, what if they don't give you a y-intercept? What happens? Can we still figure out an equation of the line? The answer is yes. We're going to look at that. Consider the line that passes through the points -1, -2, and 3, 4. We have 2 points, but none of them are y-intercepts. So how do you find the slope of the line? You can find the slope of the line by counting the changes. In an equation, your slope equation should always be y value minus another y value over x value minus another x value. Why did I put y sub 2, y sub 1, x sub 2 minus x sub 1? Because your points are different, right? One point is gonna be x sub 1, y sub 1. Okay, it's just a representation of one point. Another point would be x sub 2 and y sub 2. It just means that you need to start with the same point. Some people mix the y values and the x values up and they make up their own point. That is not okay. You need to use the same values for the first numbers, okay? So that's why we separate them, we distinguish them with the distinguished number y sub 2 and y sub 1. It means you're going to use the second values, the second point values on the second point. So whatever your first point is, you can choose which point would be the first one, which point could be the second point. It doesn't matter. But if you choose 3, 4 to be the second point, then you have to start with 4 for y sub 2. You have to start with 3 for x sub 2. Does that make sense? So yeah, if you start with the -1, -2, that's okay as well. You just have to make sure that you start with -2 minus 4 over -1 minus 3. Okay, you can't just mix the orders up. Just make sure whatever point comes first stays first. And that will be the same answer as this one, right? You still get +3 over 2. Your slope shouldn't change even if your points are in different orders. So your slope equation is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 when your points represent x sub 1, y sub 1 and x sub 2, y sub 2. Okay? There's a lot of representation going, but that's the slope equation. And step 2, now that we have figured out the slope, we need to figure out the y-intercept. What is the y-intercept? How do we figure out the y-intercept? You can use this, the equation to figure out the y-intercept as well. How do you do that? Well, think about the equation of the line. Your equation of the line y equals mx plus b. Whatever your slope and whatever your b is, they're going to be the same number in one equation of the line. Your x and y changes according to your points on the line. Your values of the points on the line determine which x goes with which specific y. So you're going to pick the points here. These points are called answers. They're called solutions of the line. So if x is -1, your y has to be -2 on the line, if it has to be on the line. If your x is -1 and y is a different number other than -2, that means that point is not on the line. So using 1 point, you could choose that, or you could choose 3, 4, it doesn't matter, okay? But the textbook chose 3, 4 because they're positive numbers and maybe it's easier to deal with. So you're gonna substitute the x and y temporarily, okay? This is not your equation of the line. You're just substituting it temporarily so that you know what b makes this equation true. Because it must be true for this point if this point is on the line. And if you find that b that makes this true, that should be true for other points as well. If you're not sure, you can also check with other points. Okay, so make sure you put 3 in place of x, 4 in place of y, and then you can solve for b. Multiply 3 times 3 over 2, get 9 over 2. Subtract 9 over 2 from 4, which is 4 minus 4.5, and that's negative 0.5 or negative 1/2. That's your b. You just figured out the y-intercept. And so that's how you figure out the y-intercept. You can still figure out your y-intercept using 2 points. As long as you have 2 points, you can figure out the slope. And then as long as you have a slope and 1 point on the line, you can figure out the y-intercept. Using that, now you can finally write the equation of the line in slope-intercept form. So your slope is 3 over 2, and your y-intercept is negative 1 over 2. That should be your equation of the line. Okay, it looks like it's a lot of steps, but you already know how to write the slope-intercept form. Just make sure that you have enough information to figure out the slope, which means you just need 2 points, and the y-intercept, which means you need the slope and 1 point. Okay? Now it's your turn. Try number 3. Write the equation in slope-intercept form of the line that passes through the points 5, 4 and negative 1, 6. You already have 2 points. You can figure out the slope, and once you figure out the slope, you can figure out the y-intercept using that slope and 1 point. Alright, pause the video, come back when you're ready for answers. Okay, are you ready? Let's check the answers. So using the 2 points, you're going to use the slope of the slope equation and figure out the slope first. That's your first step. Otherwise, if you don't have slope, you can't figure out the y-intercept. Your slope equation should be your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So whatever your points are, you can choose which point would be the first or the second. Let's just go by the order. So that could be x sub 1, y sub 1. That could be x sub 2, y sub 2. Okay, so just plug it in. Your slope is 6 minus 4 over negative 1 minus 5. And it works the other way, okay? 6 minus 4 is positive 2. Negative 1 minus negative 1 minus 5 is negative 6. So that means if you simplify the fraction, you get a negative 1 over 3 for your slope. Using that, you're gonna use the slope-intercept form, y equals mx plus b, to write y equals negative 1 over 3x plus b. And we're going to substitute one of our points. Let's choose the first point because they're all positive. And it's always easier to deal with positives than negatives. So we're going to choose 5, 4. Your x value is 5. So we're going to write 5 instead of x. And if x is 5 in your equation, your y has to be 4. Because that point, that coordinate pair, makes this equation true for all values. On that line. So solve for b. You're going to multiply 5 times -1 over 3. And that's -5 over 3. Then you're going to add 5 over 3 on both sides in order to get b. 5 over 3 could be written as 1 2/3. So you will have b as 5 2/3. Okay? Or that could also be 17 over 3 if you prefer improper fraction, that's fine. For the equation of the line, we do prefer improper fraction than the mixed number, because it's actually easier to see the equation that way. Sometimes if you write fractions in mixed numbers, sometimes it could be misunderstood as a multiplication. So we try to make fractions as improper fraction, okay? So for the equation for number 3, that goes through the points 5, 4 and -1, 6 would be y equals -1 over 3x, that's your slope, and then plus 17 over 3. So your y and x should be your variables. It should work for other points. So if you plug in -1 into your x value and you solve for this, your y must be 6. That's another way to check your answer. It must be true for those 2 points, because those 2 points are both the solutions of this equation. They are on the line. Okay, that was try number 3. Let's look at example 4 and make applications. It's the last example. Interpreting slope and y-intercept. Allie received a gift card for her local coffee shop. Every time she goes to the shop, she gets a medium coffee. That's a pattern. The graph shows the gift card balance at 2 points. How can Allie determine the number of medium coffees she can buy with a gift card if she does not know the original value of the card? So first, let's try to understand what the situation is. We see these 2 points. What do they mean? Let's look at the graph and see what x and y-axis represent. Y-axis represents the gift card balance in dollars. So all these numbers represent dollars in your gift card, in her gift card. And your x-axis represents medium cups of coffee. So how many medium cups of coffee? It's the number of the cups of coffee. So the point 2, 19.7 here would mean what? 2 cups of coffee. 2 cups of medium coffee, M-size coffee, would cost $19.7 is what it means. What about 4, 14.4? 4 cups of medium coffee will cost 14.4. Wait, whatever it costs. That's how much balance you have left. Sorry. So gift card balance is how much you have in the card. So after you use it, it goes down, right? So after 2 cups of coffee, she has $19.7 left. After 4 cups of coffee total, she has $14.4 left in her gift card. So that's what it means. And using that, we're going to find the slope and figure out the equation and see when it ends, like how many cups of coffee can she buy with her money on the gift card versus how much money does she start it from. So that could be what your x-intercept represents and what your y-intercept represents as well. Your y-intercept would be the starting value. Your x-intercept would be the number of cups of coffee that she can buy with all her money in the gift cards. Okay, so thinking about what they represent, let's figure out the slope and let's figure out the y-intercept. Using the 2 points and using the slope equation, we can figure out that the slope is negative 2.65. So once you have, how do we get a decimal? So once you have subtracted the numbers here, so 19.7 minus 14.4 is 5.3, right? And 2 minus 4 is negative 2. If you literally divide these numbers, 5.3 divided by negative 2, you get a negative 2.65. And that's equal to the fraction we have here. Okay? So you can simplify your fraction that has decimals like that by literally dividing them. So the slope is negative 2.65, which means that the balance of the gift card decreases $2.65 each time she buys a medium coffee. So that means a cup of medium coffee probably costs $2.65 because the prices wouldn't change. Okay, the cost of a medium coffee is $2.65. Use 1 point. You can just pick 1 point out of those two, and you can use the slope to figure out the y-intercept. So use the slope equation form, intercept form, to figure out your y-intercept. And so plug in the x value and the y value of 1 point. And then you're going to use the slope that you just figured it out to figure out the remaining variable, b, that stands for the y-intercept. And if you solve for b, it's going to be 25, and that is your y-intercept. And what does it represent? That means y-intercept 25, that's 22, so that should be 26. So 25 is right here. That's 0.25. What does this represent? It represents she bought 0 cups of coffee. So that's when she never used her card, her gift card. So your gift card balance, so her gift card balance starts with $25. It was a $25 gift card. And that's how you can figure out $25. And with that, you can also draw a line and figure out the y-intercept, or using the equation of the line, you can figure out the x-intercept. She can purchase 9 medium coffees with the gift card. 2.65 times 9 is exactly 25, and that's how much you could buy with the gift card. Okay, so using the x-intercept and the y-intercept and the slope and your equation of the line, you can figure out all this information in real life. Let's try number 4. Use information from example 4 to write the equation in slope-intercept form. So we haven't officially written down the slope-intercept form of the line, but we have all the information that we need to write that equation. So we've done all the work now. Writing the slope equation, writing the equation of the line shouldn't be hard. You just plug it in and voila. And then you're going to find the x-intercept of the graph of the equation. What does the x-intercept mean in terms of the situation? We already kind of talked about it, but see if you can explain that in your own words. Come back when you're ready for answers. Okay, have you figured it out? So using all the information that we already have figured it out, you should be able to write the equation quickly. So y is equal to your slope, negative 2.65 times x, plus your y-intercept, 25. That is your equation of the line. And what is your x-intercept? So if your y-intercept, what does your x-intercept mean? And how do you figure out the x-intercept? Your x-intercept is when your line crosses your x-axis. So that means all the points on the x-axis could be possibly your x-intercept, but there's only one point that goes through it. So it's going to be If you draw the line here, it's probably gonna be around here. Does that make sense? And your x-intercept point will always have a y value of 0. Your y is 0 on all the points on the x-axis, right? So your point will look like x, like a number of x, comma 0. Your y is always 0. This is the x-intercept. So if you know that your y value is always 0, you can set your equation b equal to 0 equals negative 2.65x plus 25 and solve for x. That means you have negative 25 equals negative 2.65x, and plugging that into the calculator, your x is about 9.43. So your x-intercept is about 9.43, 0. And what does this mean? So the x-axis represents the median cups of coffee. So how many cups of coffee she would have with the gift card would be your y-intercept. So let's write that down. The x-intercept is the number of cups of coffee Allie can buy with the gift card. Since she cannot buy a fractional cup of coffee, how many can she buy? The maximum number she can buy is 9. Because can she buy 10 cups? No, she doesn't have enough money to do that. So yes, she will have a little bit of leftover balance in her gift card, but she can only buy 9 medium cups of coffee. Okay. So that was our application problem for lesson 1. Let's summarize our lesson. We learned about slope-intercept form of a linear equation. The slope-intercept form of a linear equation is used when the slope and the y-intercept of a line are known. And it's the basic form. It's the first form that you always learn when you learn about equations of the line, slope and y-intercept. In order to figure out the slope, you just need 2 points. In order to figure out y-intercept, you need a point and a slope. Okay, those are the things you need to figure out them. So if you don't have enough information, that might be a hint to use another form of the equation of the line. But once you know the equation of the line, right, you can easily figure out what the slope is and what the y-intercept is by just looking at the equation. Okay, so for example, this graph has a slope of 2 over 3. Make sure you always put your y values, the change of y values on the numerator, change of x values in your denominator. So 2 over 3 is your slope. Y-intercept, as you can see, is 0, 1. In this graph, your y-intercept is 0, negative 1. And your slope is negative 2. Because you have negative 2 over 1, that's equal to negative 2. Okay, that was slope-intercept form in the first lesson. If you have any more questions, you can ask Ms. Kang in class. Otherwise, we'll continue with the next lesson, lesson 2, point slope form, in the next video. Thanks, guys. Bye.